Hello everyone. Is my screen visible? Am I visible to you all? Hi Muthu Kumaran. Hi Bhanu. Hi Nasargi. Hi Harsha. Hello Bhagwati. Hello everyone. So wait for uh, let's wait for 5 minutes. Let everyone join in. Hello Anshuman. Hello Shubham. Hello Gayatri. Let everyone join in. Well, we will wait for just 5 minutes and then we'll start. Okay. Good evening, Vidya. Hello Ansh. Hello Janvi. Every day, how much you will I guess it will not be long. We will have around 80 minutes to 90 minutes lecture every day. So I'm audible to everyone, right? Hello, Sanidhya. Hello, Aarti. Hello, Chitra. Hello. You can maybe tell your friends about it and you can tell them to join. We will be starting in just 3 to 4 minutes. Hello, Satvik. Hello. Hello, Shristi. Hello, everyone. So make sure you have like your a laptop or at least a notebook and a pen with you all. Today we will be just talking about introductory part of dynamic programming. We will do some codes, but not much. And I will share the notes and all with you. So even if right now you don't have laptop, you're watching it on a mobile phone, at least make some notes. At least have a notebook with you all. Yes, yes, Arshit, it will be. Hi, Shrishti. Hello. We'll start on sharp 7:10, just 2 more minutes. Voice getting twice. Is there an echo? Um, Sandhya is saying there is an echo. Is there an echo? Can someone confirm? Mm, Let me check on my end. It's fine, right? Thanks, thanks. Okay, okay. So I feel we should begin, right? I think everyone is. everyone has joined. We begin at 7:10. Let's wait for some people to join. I guess some people will be joining. Okay. So good evening, everyone. Um, Welcome to DSA Bootcamp, precisely Graphs and Dynamic Programming Bootcamp. So in this bootcamp, we'll be going through from bottom to top. We'll be talking about dynamic programming and graphs. So this is the day one. Today we'll be talking about, for example, dynamic programming. We will introduce dynamic programming. What is dynamic programming? Why it is needed? What was the need of it in the world of data structures and algorithms? And then we will see some elementary problems where this dynamic programming approach helps us to optimize stuff, right? And then we'll solve some problems. Then we'll solve some 3 to 4 really good and popular problems for dynamic programming. You must have been familiar with, I guess, a lot of you must be familiar with Fibonacci numbers and climbing stairs, such popular problems. We'll go in depth, analyze them, their time complexity, space complexity, talk about how dynamic programming helps us in in this in optimizing these recursion based problems. Hello Junaid, hello Jaya, hello Gopika. Yeah. So let me just. Are there any prerequisite we should know for this course? There are no as such prerequisites. I'll be using C++ language, so I believe that all of you must be familiar with some language, not only C++, like not just C++, any language. I'll be talking about like algorithms. So I'll be talking about in terms of pseudocode. So language specific will not be a lot language specific. I will be giving you solutions in C++. In notes, I will also give them in Python. Don't worry. Um, but I will give you the algorithm. You can code it in your uh, favorite language, in the language, in your favorable language, like whatever you like. So let's begin. So is my screen visible to you all? Just tell me once. All right. Is it visible? Yes, it's visible. So let's start with dynamic programming. So how many of you have like how many of you like tackled some any problem or have heard of this technique known as dynamic programming? Uh, this this is really like a very nice and optimizing technique. Like it's not a algorithm, it's in terms of as a whole, but it's an optimizing technique. So let me first define what is dynamic programming. Um, it is simply an optimization over recursion. It is as simple as that. Like you all must have like created a havoc of it. कि भाई, what is dynamic programming? Oh, I'm not able to do dynamic programming. It just you know an optimization over recursion. Like you all must have done. Will not be diving deep into problem solving as of now. First, I will uh, define dynamic programming. Then I will define some approaches about dynamic programming. But just to give you an idea, a lot of you must have done this problem of this famous problem based on Fibonacci numbers, right? That one, this is a Fibonacci sequence. Most of you must have been seen somewhere or the other. Yes, Tanya says yes. Avinash, today we will start with dynamic programming. We will go with the basics of dynamic programming and we will talk about some problems. And then tomorrow we will dive deeper into some problems like two-dimensional dynamic programming, DP over subsequences. There is a concept known as dynamic programming over subsequences. Uh, and then we will talk about some more tough problems towards the end of day 2 and towards the starting of day 3, like dynamic programming using binary search. And don't get scared, we will go step by step. It will all feel super, but I'm just giving you an overview because Avinash asked it. Hello, am I audible now? Am I audible? Am I audible? Yeah, yeah, sorry for the, yes, okay. Sorry for the delay. All right. So we were talking about dynamic programming. So I guess I explained the flow of the bootcamp. I guess Avinash pointed out uh, the flow. So just I will write it down here. So flow I will, this is day 1 DP intro plus 1D, day 2 DP 2D plus subsequences, and then day 3 we will talk about graphs intro plus elementary problems, and then day 4 we will go deep into graphs, like graphs, hard to medium problems. And then day 5, we will see some problems which include DP on graphs. It sounds tough for now, but it's DP plus graphs. So this will be the flow. Okay. I will share this, these notes with you, so there is no need to note it down. So what we were talking about, what is dynamic programming? It is just an optimization over recursion. You must have done this Fibonacci sequence, or maybe some problems including recursion, right? Even for example, a lot of people must have done 2 raised power x problem, 2 raised power x exponentiation problem on using recursion. Like we divide it into 2 into x by 2, we divide it into x by 2, x by 2, then you multiply them, 2 raised power x by 2 to get 2 raised power x. Then you divide this into 2 raised power x by 4 into 2 raised power x by 4. So these are some popular problems of recursion, I'm telling you. Dynamic programming is simply an optimization over recursion. And how this optimization is done, there are some techniques. There are mainly 2 techniques. One is memoization, second is tabulation. Over the course of doing dynamic programming, these will be the 2 core techniques. And the beauty of them is you can choose any of them to solve a problem. Memoization as well as tabulation. You can uh, choose any one of them. They work perfectly fine. Every problem can be converted from memoization to tabulation as well as from tabulation to memoization. There is no issue in that. The core idea, now you must have seen what is the core idea behind these 2 techniques. What are we trying to achieve? So before telling you the idea, before telling you the idea behind these techniques, let's just dive into one problem. Okay, just stay with me and let's dive into one problem, right? So the problem is our very popular Fibonacci numbers. So you will be given, you will be, the output will be f of I, which is ith Fibonacci number. Okay, and input will be I. Simple as that. I belongs to just any number. Let's say 10 to the power 6. Okay. Now think about, you don't know dynamic programming. How will you proceed with it? So I already mentioned, like legally. So ideally someone should define what is Fibonacci number. So Fibonacci number is defined as, for all I, f of I equal to f of I minus 1 plus f of I minus 2 should hold. This is the definition of Fibonacci series, right? Clear? Is this clear to everyone? What is Fibonacci series? And obviously this whole recursion is not valid at I is equal to 1 and I is equal to 2. So we define f of 1 and f of 0 to be equal to 0, to be equal to 1. Okay, is this clear to everyone? Okay, Sadikul says yes, Janvi says yes, Monisha, it's clear to Jim as well. Nice. Okay, so this is clear, right? We have defined Fibonacci numbers. This is the definition we needed. This correct definition, I guess. We need these corner cases, right? Because you guys can see it, right? We think of f like an array, so it's not valid. F of 1, it's f of 1 is equal to f of 0 plus f of minus 1. It's not valid, right? Exactly, Ravi. Sequence of numbers in which each sum is equal to sum of previous two numbers. I've just written it in a more mathematical definition where I've defined it as a function. That definition is right, whatever you're saying. Okay, so let's just think about it. How can we solve it? Okay, so first approach that comes to my mind is we can just call. Let's just call our array as Fibo. I can take int I as input. Okay, so let's just recap. How did we used to write a recursion? Recursion used to have a base condition. That's how it's important because then it will run infinitely times, right? A base condition and the main code. So basically, this is how you used to write recursion codes. There should be a base condition, and here we should have the main code. So clearly we can see this is the recursive function and this is the base condition, right? We can see it but that's why I defined it in a more mathematical way, because it's easy to see that this is recursive and this is the base case. Okay, so we will simply let's just, if I equal to 0 or I equal to 1, return, oh maybe not like this, simply if I equal to 0, return 0, and if I equal to 1, return 1. Okay, I'm really sorry for the handwriting part. And then you simply return Fibo I minus 1 plus Fibo I minus 2. This works, right? Let's just check our algorithm. I have a question for you all. Just let's just code this, right? You can simply go to Fibonacci number lead code and then find the first link. And I just showed you a pseudo code for this problem, and we can, so let me just briefly tell you how do you approach a problem on any of these comparative platform. First, read the problem. The Fibonacci numbers completely denote f of n, commonly denote f of n, form a sequence called the Fibonacci sequence, such that I guess you guys should read it. I've just kept it open for a while. Let me read what you're saying. Clever Phoenix says, can I solve these most DP by following this? Yes, you can see in, obviously, in like how many hours? In 3 hours, 4 hours, I cannot cover every problem on DP, but I will cover every pattern, right? So I will cover, for example, 1D DP. I will cover 3 problems for 1D DP, and then you can do every problem of 1D DP. Same goes for 2D DP. Same goes for DP on subsequences. Same goes with DP on binary search. So I will cover every pattern, and then because every problem is from that pattern, so you can then tackle every problem related to dynamic programming, right? And towards the end, I will also discuss dynamic programming on graphs. So you will be good to go with all problems of dynamic programming. So I hope everyone has read this problem, right? Just tell me once if everyone's done with this. Everyone has read the problem. It's just the same problem we were doing, and they have also defined some of the recursive equations. Now note that, okay, Bhavika says yes. Okay. Now note that the constraints. As this is a introductory, like they have kept it easy, so they have kept constraints also like 30. Uh, so, but we can even solve this problem if this constraint was not 30, if it was something bigger. So first let's code it up. Let's code the solution first. So let's see how what's the thinking process. The thinking process first is let's just write our main equation. So this answer will contain the answer for, and then we will simply return the answer. Is there something missing in this? Did I miss something? Maybe not. Let's run my code. Oops, there is an error. It shows deadly signal. What did I miss in this? Can anyone help me point it out? Uh, Clever Phoenix says base condition. Uh, if recursion don't stop. Yes, you're right. Yes, Balaji, you are right. If n is equal to 1, then return 1. Darshini, you can simply go to, like, you can simply do Fibonacci lead code, and the first link you find is this. Yes, you all are right, Dinesh. Um, please zoom in. Okay, okay. Is it visible now? I have zoomed in fairly big enough, I guess. Recursion not stopping, base case is missing. Yes. Vanshita, yes. Devajyoti, yes, you all are right. So we should write base condition. If I is equal to 1, return 1. And I is equal to 0 is also mentioned, right? So we should also write if I is equal to 0, return 0. Okay, now this should work fairly fine. Yes, this should work. You can see like every case is accepted, right? Let's just submit our solution. So we have for now we have done this solution with what we knew. Okay, so this is accepted. You can see here it gets accepted. So for now, you can see the performance of the algorithm is not that good. You can see in runtime. You can see it here, like the runtime, the memory. It's not the big issue is runtime. So let's optimize this. Let's optimize the recursion. How can we optimize this recursion? So I talked about. Let's come back to this. I talked about this Fibonacci numbers code. Let's just dive deeper into it, right? Let's just dive deeper into it. For example, let's say, for example, no, Muthukumaran, this is not DP solution. This is just simple recursion solution. Now I will tell you how to convert this into a DP solution. Let's just stay with me and think about f of 5. How our computer will be, how the algorithm will be generating f of 5. It will be generating f of 5 like this, f of 3, f of 2. Maybe I should write it below here. So what we are making is recursion tree for Fibo. This is what we are making. Let's just calculate for f of 5. Okay, let's just, okay. So first we'll go f of 4, f of 3. and it will sum it up. Is it clear? Like for f of 5, it will go for f of 4 and f of 3 because I minus 1 and I minus 2, right? And then for this also, it will go to f of 3 and f of 2, right? And then for this, it will go to f of 2, f of 1, f of 2, f of 1, f of 1, f of 0, f of 1, f of 0, f of 0, and here recursion dies, right? Okay. So this is the recursion tree now. No, there are some key observations here, right? Just look closely. F of 3 is been computed twice. Can you see it? F of 3 has is been computed twice. Yes, Devajyoti, you are right. By the DP we can optimize. We are optimizing. We're just going step by step. For now we are seeing why there is a need to optimize and how we can optimize. Why we have seen, right? We have uh, we have coded a here is a brute force solution. We have coded it up. We have seen the performance is not that good. So the why is clear. Why is clear to everyone, right? Why we are trying to optimize. So if why is clear, then we are saying how. How do we optimize? So we see the recursion tree for Fibo is something like this. We are calculating f of 3 twice. We are calculating f of 2 4 times. No, f of 2 we are calculating 3 times. You can see here and here. Right. We are calculating f of 1 4 times. So this there must be an optimization for this because maybe we can. So first our computer will go in f of 4. Our algorithm will f of 4 here. Then we'll go f of 3. Then we'll go f of 2. Then we'll go f of 1. Then we'll go f of 2. It basically do a. It will. I won't go. I won't say DFS because then you guys will say what is DFS. I will say simply it will go to the depth first. First here, then here, then here, then here, here, then here, then here. Okay. So my argument is, can we, if we have gone here first, then why are we calculating this whole tree again? Think about it. Think about it. If we have gone to f of 2, the tree of f of 2, then why are we going again here? If we see maybe if there is a way we can store the result for this, we can simply see that result and go back. We can simply save this computation time. Can we do that? Think about it. So now let's come back here. The core idea of these. Now, can someone guess what is the core idea for doing uh, these two techniques? What's the core idea behind these techniques? Yes, GTech says yes, you can. Yes, Devajyoti, correct. You are right. So, idea is store the result. Simply store the result. You can store this f of 3, this f of 3 because this is computed first, and then use it here. You will never go here. You can simply go back, right? Exactly. Store previous elements. Suruchi, you are right. Deepthi, right. Clever Phoenix, right. Exactly. You can store the solution. So think about, if we store the solution, how amazingly this tree changes. I just f of 1 and f of 0. Now the tree is complete. Now think about how this tree changes. Think about it. Your algorithm will go to here, then it will go here, then goes here, then goes here, then goes here. It never goes here because you have calculated f of 1 here. It never goes here because you have calculated f of 2 here. See the beauty of it. It only goes to these many nodes, right? Uh, Monica, not actually. She's saying there was a space complexity issue. We will come onto that space complexity issue. What is the space complexity? Okay, we will come onto that. It will not be much. Uh, okay, so let's just store it. We simply came to a conclusion. We keep an F array of in our case let's take 5 length. Okay, in our case let's take 5 length, and then we will. This is the initialize step. This is the initialization step. Is this clear to all? This is how we'll be initializing. Okay, and if this is how we are initializing, we can actually come up with a more optimized way of this. Fibo um, optimized. Now think about it. You have already created an array. Now you can simply do this. If f of I not equal to -1, return f of I. And here we can do the same. Fibo. We can simply return f of I equal to Fibo of I -1 plus Fibo of I -2. Is this clear? That's how will we be needing. Okay, so just so that you guys don't get confused, we will be doing this. We have initialized the variable. We initialize this f outside the f function and a Fibo function, and then we will be calling return Fibo I. Let's assume we will be having some I input. Okay, so as you can see, we have shifted the base conditions from the function to here. We will initialize the f function in such a way that base conditions are valid, right? Okay, so let's range maybe overflow to. Okay, you are saying there will be an overflow in this. No, think about it. There will never be an overflow. The condition we were given is I will be always be less than equal to. For example, in this case, we can even take 10 raised power 3. Okay. Now, will there be an overflow here? No, right? Because at every point you're just going at I -1 and I -2, and if you have covered 0 and 1, for example, let's just Let me show you on a number line, right? Let me show you on a number line. This is 0. This is 1. Assume you are standing at any point here x. Can you ever can you ever hop from this x in such a way that you skip these 0 and 1? Is there a way that this happens? Keep in mind that you are always going x I minus 1 or I minus 2. Will this ever happen that if you are hopping from x and you're just going minus 1 or minus 2, you will always skip these two? You will never go on either 0 or in 1. Sanatana says no, no. Right. Yes. So this will never happen, right? Either you will be landing on 0 or there would be a case you will be landing on 1. If you will not be landing on 1, then we know you were on 2. You have not landed on 1, let's say. We know that you were on 2, now you land on 0. This case is the only case. Utkarsh, yes, you are right. This will never happen. Hazel, you are right. No, Pradeep, right. Yes, you are all are right. So I guess Bhavika, you understood, right? There will never be an overflow for this. Um, so we can simply optimize this. So in order to optimize this, let me just create our own function Fibo. This is Fibo. And uh, am I audible now? I guess it's now audible. Okay, let's proceed. Let's proceed with what we were doing. We have written the base cases and we have initialized f. So what I was saying was f, this statement initializes a vector. Vector is an array basically, a dynamically changing array of size I plus 1 with all entries minus 1. Okay. Okay. Let's focus on how we are using DP. We are spending some time on this because we have seen how we are applying DP, why we are applying DP on this. We have seen the recursion tree and all. Let's just quickly code down our thoughts, what we all agreed upon. Let's Fibo of I, and then according to our Fibo of I minus 1 plus Fibo of I minus 2. I guess this is okay. If f of I not equal to minus 1, return This works fine. This works fine. This works fine. So, can anyone in the chat tell me, is there any error in this code? Is there any error? I give you just 1 minute to spot that error. I will not run because then it will be quite obvious. Can you tell me what's the error in this code? We have penned down, I guess we have penned down all the thoughts. You can even call this a helper function. Two functions. Two function is not an issue. Method overloading. No. It's a very obvious it's a very like obvious mistake, but we have done it in such a flow that it's it's getting tough for you guys too. No, Tanisha, we have written f of 0 is equal to 0. Method overloading. No, there will not be any method overloading. It's simply right. If we calls help of I, then help of I gets called recursively, and then at some point it stops, and then we get return. Exactly, Karthik, you're right. Vector is not passed; it is local in main function. It is a local in main function. We have to write. We have to pass it here. Um, Vector int f. Exactly, Prem. You are right. Scope of vector was the problem, and then you have to pass it by reference because you have to change the values, right? What's acha? I will change it here as well. Now this will run. Let's see. Yes, it runs perfectly fine. Let's just try and submit this solution. Oh, what's the issue here? Oh, okay. Uh, let's just do this. Now see. Now compare this with the previous approach. The runtime is improved drastically, right? The runtime of the previous solution and this solution has improved drastically. So let's just dive deeper of what changed. What did we change in the solution? This is the code we used, the classic memoization approach, compared to this recursive approach. Can someone just quickly tell me the space complexity of this approach? The previous um, the space complexity of the previous approach, this the recursion based approach that we used. So I think the space complexity for O of n, Devajyoti says O of n. No, Devajyoti, I'm asking for the space complexity of this code, of the recursion code we wrote a while ago. The recursion code. Can you guys think of it? O of n, O of n, O of n. Okay, so let me tell you the recursion. The what we're doing here is we're just calling recursion. So time complexity here will be O of 2 raised power n. Now let me tell you why. Let me just tell you why. Um, let me just tell you why. What you are doing, think about it. Think about it in this manner. Actually, not 2 raised power n. O of 2 raised power n is correct. O of 2 raised power n is correct. Just look at it in this manner. How many nodes are you actually processing? 1, 2, 3, 4, 5, 6, 7, 8, 8, 4, 2, 1. They're close to 16. So recursion stack, the complexity of recursion stack is also there. Exactly. And what's the space complexity? Space complexity, the time complexity is also O of 2 n, because at every moment you are dividing in 2. Think about it. If there was f of 2, then f of 1 was getting called, f of 0 was getting called. So 2 raised power n was the time complexity. Now, after optimizing, what do you think is the time complexity? First, let's just, because space complexity is easier to think of. First, let's just think, what is the space complexity? Can anyone tell me what is the space complexity of this optimized approach? Again, first think of declared stuff plus recursion stack. Think of these two together. Although recursion stack is not that big in this one. We have already seen the augmented portion in DP, right? Only this much was getting called. So think of Nitin Verma. Yes, space complexity is O of n. Exactly. Space complexity of O of n because of this statement. This statement, can anyone see it? Everyone see it? It increases the space complexity to O of n. I mean, increasing from nothing to O of n. And the recursion stack takes, in this case, O of n. Is it clear? So let me erase this. Time complexity is O of n. Space complexity is also O of n. Okay. And see, we have drastically improved our solution. Now, just to wrap up the introduction of, not wrap up the today's session, just wrapping up the introduction. You guys just can read this from CPH handbook. Um, they have defined it very nicely. Dynamic programming, finding an optimal solution, counting the number of solutions. What we have done in this case is, they are saying dynamic programming is used in two cases: finding an optimal solution and counting the number of solutions. We have kind of found an optimal solution because first solution was by recursion, and then we optimize that solution, right? So you guys can have a brief read on this because we will be doing some problems uh, mentioned in this book. It is a really nice book. You guys can simply look into it. Now, to practice more, let's just uh, let me just introduce you to one more problem. Uh, we will do this climbing stairs. Yes, Sanku, I will try to share that PDF in the DevTown group. Yes, I will share it with the DevTown group after the session. Okay, after the session I will share because you have to anyways read it after the session. So I will share it. Don't worry. I will share it with the notes. Don't worry. Now the climbing stairs problem. Everyone, please read this problem thoroughly and try to think of an algorithm to solve this. Try to think of an algorithm. Try to write that pseudocode in the chat. We will wait. We will wait for you to think of. Try to think of how we can proceed in this one. Yes, Avinash, I will share it after the class, after the session. I will share it. Don't worry. You don't have to read it right now, right? You have to read it after the session. I will share it. Don't worry. Try to read this problem. So you're climbing a staircase. It takes n steps to reach the top. Each time you can either climb one or two steps. In how many distinct ways can you climb to the top? Now remember, there are two scenarios in which DP is used. Finding an optimal solution, counting the number of solutions. So this is the counting number of ways you can climb the stairs. Think about it. Think about it. Yes, Tina. Similar to Fibonacci. You are thinking in the right direction, right? Actually, let me just take 2 minutes and uh, you can even solve this problem like this. Oh, let's just do J. You can even solve the Fibonacci problem. You can even solve the Fibonacci problem using tabulation. I've just tabulated this stuff. There is nothing fancy I've done. I just because I thought that many of you might be confused and you use memorization. Why not use tabulation? This is how you can tabulate your solution. And it is clear to see, right? This loop makes it O of n, time complexity O of n, and this statement makes it space complexity O of n, right? Right? We can see it, right? Everyone can see it. The space complexity. I can maybe have a comment here. Space complexity O of n, and this thing makes. Oh, this thing makes space complexity O of n, and this stuff makes time complexity O of n. We will be covering the use of graphs and graphs. No, no. We will not be going into rags. We will just be using. We will just be introducing graph with a perspective of solving data structure and algorithm problems. Retrieval augmented graph. No, we will not be. We will not be introducing those things. Maybe we will introduce them in some deep learning deep learning class, but not here. This is a data structure and algorithm bootcamp. We will be just doing this. Okay, so let's just um, try solve this problem. Okay, so I feel like everyone has read this problem. Let's just try to think about a solution for it. So let me just see how different we can climb to the top. Okay, okay, so we have to reach just let's just make a stair. You have to reach here, right? You are standing here, the bottom part. User is problem is asking how many distinct ways are there to reach here. Can you think of a possible solution to this? Can someone in the chat tell me the recursive function for this? Let's just say I define f. Okay, let's just define ways of I equal to number of ways to reach ith step. Now can someone give me the recursive function for this? What should be the general recursive function for this problem? For example, if this is ith step, this is I plus 1th step, this is I minus 1th step, this is I minus 2th step. Shubham says, is it good to do DSA using Python? It's it's okay to do DSA in Python, Shubham. Like there is no as such there is no problem in doing DSA with Python. I would prefer try if you are starting, try to do it with C++ because um, you will see right now if I try to explain it, you will see that C++ runs. If I have to just make a generalized statement, C++ runs faster uh, as compared to Python, and in many competitive contests, like this um, C++ gives you a slight edge over the users using Python. So if there is a uh, if there is a choice, choose C++ if you can. But if you know Python, then and you don't have and like you don't have much time to learn C++, there is no such problem in using Python. It depends. Like for interviews, it's perfectly fine. Perfectly fine. When I said in terms of C++ is slower uh, when compared to Python. I was talking about the competitive programming context. Their minute detail matters, right? Yeah. So Dinesh actually pointed out perfectly way of I equal to yes, exactly. So let's just define. So if you see if you're standing at this step, pretty simple. If you're standing at this step, you will you either come from this step or from this step, right? So I guess now everyone is able to form the recursive solution. for this one. Right. This is the recursive function for this. Yes, Bhavika, right. Yes, Pradeep, you're right. N minus 1 and n minus 2. So we'll be having ways to reach one will be one, ways to reach two will be two. This will be the base condition. Base condition. And let's now code it up. Code our solution. Let's just check with the um, yes, for two they have given answer as two. So just check the constraints. Okay. Vector int ways. Uh-oh. Hmm. What's the problem in this? Can someone point out the problem in this approach? Okay, so we have shared the attendance link with you all. You can all mark the attendance. Yes, Chirag, it's shared on the chat. You can mark the attendance. After marking it, just think of what's the issue in this. The size of the vector. No, I have declared the size of the vector here. So Ruchi, there is no problem in size of the vector. Think of it. Think of it. Quickly mark the attendance and come back. Do you guys think there is a problem in this code? Because it's giving wrong answer for n is equal to 2 and n is equal to. Kindly pass the vector. No, there is no. We have not created another function, right? So there is no problem in that. Vector not passed. Exactly, Vishwas. You are right. Exactly. Appa pointed out first, uh, and Vishwas is also right. Yes, Paul, you are right. Yes, Saurabh, exactly. Base conditions we have not mentioned. Because I'm doing these mistakes because you will do these mistakes a lot. Ways of 1 will be equal to 1, ways of 2 will be equal to 2. Yeah, exactly. Let us just submit this. I believe this is right. Oops, buffer overflow. Okay, there will be cases where ways of two will not be valid. Yes, this is the right code for this. Can anyone just quickly tell me the uh, the time complexity and space complexity of of this approach? Fast, fast. Just look at this solution and tell me the time complexity and the space complexity of this approach. Often, Suruchi, right? Right, Shubham. Right, Nitin, right. So often. Right, right, right. So yes, we guys can see that this loop makes it O of n, and this declaration of array makes it O of n in terms of space. By using I plus 2 size of vector. Actually, Suruchi, you can let me just let me just point it out here. Actually, what we are doing in cases, we are we are using these conditions. We are applying these conditions in every scenario, right? Let's take for instance. So let me just write a part of our solution. Vector of int ways n plus, let's just say n plus 1 comma 0 comma minus 1, and then we have done this. Ways of 1 is equal to 1 and ways of 2 is equal to 2. Now think about it. If what would happen in this case if the input is 2, uh, not 2 actually, just think about it. If the input is 1, think about it. What will be the issue in just this statement, just this part of the code, if input is given as 1, which means n is equal to 1. The n we are using here, this is equal to 1. Is there any problem? The issue is the issue is this one. Think about it, how the array is declared. When we say n equal to 1, size of 2 minus 1, which means array will be declared like this: minus 1 minus 1. This is index and this is value. Do you see what's the problem here? We are accessing this part, ways of 2, which is not present. So this will give us an error, segmentation fault we call it. If we are trying to access a memory which is not present, then it's segmentation fault. So this is segmentation fault. I mean, if I do this as 1, just see what will be the error. we will be, if I submit this, heap buffer overflow. This means that you are trying to access this address written in hexadecimal form, which is not present in the memory. Okay, out of index fault. Yes, Pradeep, you are right. Yes, Pradeep, exactly. Out of index. So that's why we are using n plus 2. Okay. So we are approaching towards the end of today's session. I will try to, let me just give you a glimpse of what we'll be talking in the next session before we leave. Um, um, House robber problem. We'll be looking at this one more problem of 1DDP. This is a little tricky problem. Okay, let me just, I've solved it before. Let me just remove my code. Um, okay, so first tell me, does anyone have any kind of doubt in this problem? Then we will go onto that problem. That will be the last problem of the day. House robber problem will be the last one. First tell me, is there any doubt in this problem? Climbing stairs problem. I'll wait for some time. You can ask any doubt you have. This was just a problem I gave to build your idea you established in the Fibonacci one, Fibonacci's problem. Is there any doubt? Yes. Yes, Prabhu, I will repeat the new problem, but first I am just waiting for the people who have doubt in this one. Is there any doubt in this problem? Okay, Saurabh. Okay, got it. Is it clear to everyone how we are incorporating that idea we used in Fibonacci problem into climbing stairs problem? If there is no doubt, then we'll proceed. Okay, Nitin. Okay, Pradeep. Okay, okay. Please explain about that base. Um, okay, Shraddha. Okay. Let me just briefly tell you, if these are not specified, think about it. If this is not specified, then the whole point goes wrong because we are doing, let me tell you this, we will doing ways of 3 equal to ways of 2 plus ways of 1. Now we have not initialized this. So what will this give? This will give minus 2 because this is minus 1 and this is minus 1, right? Okay. So that's the problem if we don't initialize the base conditions. And so I hope, Sayed, it's clear to you why we have used base conditions. And now what we're trying to do is we are trying to optimize our recursion approach into O of n, into an O of n dynamic programming approach. We are doing it using tabulation, using an array. We have tabulated the solution in that array. Now think about it. If you have 1 and 2, the answer for, just give me, those who have understood, just give me 2 minutes. I'm just clearing a small doubt. Um, let's say, I mean, for this problem, let's just say you have this, right? This is first step, this is second step, this is third, this is fourth, this is fifth. Now, if you are standing some, let's say at an arbitrary step, what we are trying to do is we are trying to simulate the process. You are at 0. There is one way you can go to 1, right? Now, similarly for 2, oh, similarly for 2, there are 2 ways. You're standing at 0. You can go to 1. Either you can go to 1 and then go to 2, or you can directly go to 2 because you can also jump twice, right? So we are trying to simulate this process till we reach to that ith, matlab, to that nth stair. Okay. So we are trying to simulate this process using dynamic programming. And how are we reducing the computation? We are storing these ways for every value less than that n. For every stair we are storing, because we are starting from 0 and then we're going to 1, we're going to 2, then we're going to 3. So we are storing this in an array. Is it clear? Okay, it's clear to Sanatan. Okay. Okay, I hope it's clear. Okay. I hope it's clear. I guess okay, so yeah, it's clear. I guess Shraddha asked that doubt. I guess now you get the core thing what we are trying to do in this question, right? The core idea of this problem. So this is the next problem we'll be looking at, house robber problem. Now this is the last problem. Just uh, we'll look at for a while, and um, the house robber problem. Read it, read it. Try to understand what the problem is asking. Okay, try to understand what the problem is asking. So you are a professional robber planning to rob houses along a street. Each house has a certain amount of money stashed. The only constraint stopping you from robbing each of them is that adjacent houses have security systems connected, and it will automatically contact the police if two adjacent houses were into on the same night. Given an integer array nums representing the amount of money of each house, return the maximum amount of money you can rob tonight without alerting the police. Try to think of this problem. So you can take this problem as an homework. Be honest. Try to think of an idea, because anyways I'm going to discuss it tomorrow. So try to think of the idea. Try to think where are you getting stuck, because this is not that straightforward. Uh, this is not as straightforward as the previous two problems. This is a little tricky. Try to think of how you can solve it. Uh, what are the problems and the approaches that you have thought of? Try to think of them, and we will discuss everything. Like, we'll discuss your doubts, your approaches, what's the point, what's the problem in your approaches tomorrow. So try to think of it before coming to the next session tomorrow at the same time, 7 p.m. Yeah. So that's it for today. Um, take this problem as a homework problem. Those people who have any doubt for today can stay, else the session is over um, for you all. Can I use another? Debajyoti, yes. Yes, Debajyoti, you can use any other language. You can see there is option for a lot of languages in LeetCode. You can use the language. Okay, thank you. Thank you, Saurabh. Thank you, Retake. Thank you. Thank you, Nag. Thank you. So I will wait for a while for anyone who has any doubt uh, for today's session. Do try to solve that house robber problem. I will share the notes, and I will also share the snippet of CPH book, Dynamic Programming. You can have a read of it. You can read that, some portion of it. It will be thankful. C language is good. Yes, DTAG, it's good. Thank you. You're welcome, Utkarsh. Welcome, Aranya. Welcome. Yes, DTAG, it's uh, decent. You can use C language. I just feel like C language is, maybe you can use C++, because C language code is code is a little, like, for even simple problems, code gets a way too much bigger. So you know, you wanna cover up recursion. I can introduce recursion a little. I can tell you from where you can study recursion, because if we get into recursion, then we will not be able to go into the depth of DP. Maybe before coming to the next session, you can study recursion a bit. Try to solve any problem of DP uh, with recursion. Do this, and in every problem you will get time limit exceeded. If you get time limit exceeded, this means your algorithm was correct. Only thing you are getting stuck is time limit. So try to do this for the simple DP problems. You can do 1D DP problems now. Try to do those 1D DP problems with recursion, and then solve the time limit issue. You will you will understand why that you will even with that practice you will understand why DP is so amazing. How can we identify? Um, we will see. That's why we are covering patterns, useful patterns. If we will um, if you will solve decent number of problems for every pattern, then it intuitively becomes very easy to identify if a problem can be used by DP or not. And DP important defines the placement of software role Yes, yes, Akanksha, it's very important to do graphs and DP. Some MNCs ask these in their OAs and interviews. Some famous MNCs have a history of asking graphs. Um, a lot of graph problems. So surely this is very important topic. Any other doubt to anyone? We will be ending. Vedai is dynamic programming is all about writing algorithm. No, dynamic programming is all about optimizing the recursion part. It's just an optimization for recursion, because you can solve those problems if time limit was given low, then there would be no need of dynamic programming. The point is we need to use this approach for scaling the systems. It helps a lot. It saves computational resource because we are doing it in less time, in less space. How we will be getting our notes? I will have to talk with the team, but you will surely get notes. I think um, you will get uh, you will get it on your group, or maybe we will find a way to share. Okay, I think all the doubts are cleared now. Okay, see you all. See you all in tomorrow's session. I am again repeating. Try to think of that problem, house robber problem. It will give you a, even if you fail, try to fail as many times as you can. That's what I will say. Try to fail as many times as you can, because then you will see that problem with different perspectives, and then when I will explain the solution, it will be more clear. So try to fail as many times as you can, and if you get the correct answer, then it's amazing. It's more amazing. Okay. Okay. So bye bye everyone. We will meet tomorrow.